Okay, guys, so we're going to start off with this is our Algebra 1, Chapter 1, and it's our first unit. So we're going to look at some simple, these are called one-step equations. Now, the interesting is that our first one is not technically a one-step equation because we do have to do something else, but in general, once the problem is set up, you only have to do one thing to find the answer. We're going to start off with something that hopefully you guys can understand or have seen before is, Joe has 4 bills and they total $80. And if you think about it, how would you solve that? Well, you'd be like, okay, well, Joe has $80 and he has, we're gonna just we'll draw those squigglies, and he has 4 bills. What bills, if we add them together, give us 80? And you might think, okay, let's just go through it. Does one work? No, that's $4. How about $5? No, if it's a $5 bill, it's only 20. If it's $10, it's only 40. Oh, it's actually $20. So how do we figure that? We kind of went backwards. We said, we have 4 bills, and we don't know what our bill is. We're just going to call it X. 4 times what? And that's kind of what we did. We kind of did a little bit of a guess and check on how it is. We did 1, 5, 10, and 20. But how could we do this without guessing? Well, the idea is that we have 4 bills. We don't know how much they cost, and we have $80. And so our one step is going to be to divide by 4, which would give us 20. So that's what it means by one step. We only did one thing here to give us our answer. And so let's go on to our next problem. Now, what's interesting is we do need to know what PEMDAS is for this. So parentheses, exponent, multiply and divide, add and subtract. And now, why is this important? I'm going to show you 2 different things. The first thing we're going to do is say, okay, what is happening to X? Well, if we look at it right here, what is happening to X? It is being subtracted. So what that means is to solve for X, we would need to do the opposite. Well, what is the opposite of subtraction? It is addition. So X is being subtracted by 3. So we need to do the opposite. We need to add 3. And X is going to equal, now the key that we need, this is -5 plus 3. So I'm going to do a number line, and you can do this in your head. This is not something that has to be done every time, but I do want to show you how this works. This is 0, -1, -2, -3, -4, and -5. So we are right here. When we add, we go to the right. So we're going to add 3. So we're going to add 1, 2, 3. So X is -2. Just a nice little way of showing how this works. Now we're going to go to the second problem. What is happening to Y? Well, Y is being added to 0.8. What's the opposite of addition? So we need to subtract 2.8. Now this is a little bit more difficult because I'd have to have a really big, long number line. So I'm going to try to make this look as neat as possible. 1, 2, and we're gonna put little dashes. So let's make this make this 1, make this 0, -1, -2, and -3, and do dashes 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sorry, I'm running out of room. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not that close enough. So when we subtract, we go to the left. But where do we go to the left from? So we start at 0.9, which is roughly right here, and we subtract by 2.8. So 1, 2, and then we have to go 0.8. So we're at negative 1.1 right here, and we're going to go another 0.8. 1, so we go, I'm gonna kind of like zoom this in type deal. This is -1, this is -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we start right here. This is kind of being zoomed out. All right, so that's us going back by 2. And then we gotta do 0.8. So 1, 2, 3, 4, 5, 6, 7, 8, which is right here. And what is that? That's negative 1.9. Now you don't need to do this like that. You can do it in your head. If you other ways of doing this is if we were to do it 0.9 minus 2.8, right? So we would have, oh, we gotta go, sorry, back up a second, to negative 2.8 plus 9. Right, so the interesting is okay, what is, can we do this? It's kind of weird, but if we went to 2.8, let's say we started at negative 2.8 and we added 0.9, we would go to the right 9 times, and that would still give us a negative 1.9. Also, another way we can do this is we know that 2.8 is greater than 9, so we know my answer is going to be negative. But then I'm going to subtract 9 from it. We have to borrow 18 minus 9 gives me 9. We have 1. This is a little bit more confusing. I wouldn't advise you guys not to do that. This right here seems to be fairly simple. Also, if you have a calculator, then that's what I would do. Okay, one step, we're solving for n. What is happening to n? N is being multiplied. Sorry, Freudian slip. N is being divided by 5. And we also don't want this to be a negative, so we're going to deal with that here in a second. So what is the opposite? We're going to multiply by 5. So we're going to multiply this side by 5. But that gives us a negative n is equal to negative 15. You're like, well, Mr. Adams, this is supposed to be only one step. Well, we could have fixed this and we did a multiply by negative 5. But sometimes that can be confusing, trying to do too many steps at once. But now we're both negative. So n is being multiplied by negative 1. To get rid of that, we're going to divide by negative 1. So we divide by negative 1, that gives us n is equal to 15. We're going to solve for x. And so what is happening to x? X is being multiplied by pi. And you have to remember, pi is a number. It's basically 3.14. So we can divide that. So we're going to have x divided by pi. That means x is equal to -2. All right, we'll give you a second, see if you can solve this. All right, so what's happening to g is being multiplied by 5, so we're going to divide by 5. G is equal to 4. Y is being divided by 7, so we take opposite. Now, there's also another way, which you may have seen before. We can make this side a fraction, 1 over 1. And we can do something called cross multiplication, which makes us y is equal to 7. Or you could have just done y, you could have multiplied both sides by 7. Doesn't matter. Either way would work. Okay, give you a second to work on these. Pause if you need to. Okay, so P is being subtracted by 11. The opposite of subtraction is addition. Now I will say this is what gets a lot of people confused when we do it with my students. So I am going to do a number line just so that we're clear. We're adding 11, so we're at -14, we're going to add 11. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we're right here. So we count from 0, -1, -2, we are at -3. The second problem, this is kind of strange. We're multiplying by 3/7. So you could do something else called multiplying by the reciprocal. I can multiply by 7 over 3. These cancel, so it leaves us with m on this side. You can simplify first if you want to, or you can say 6 times 7 is 42. And like with anything good, then we have to simplify this. M is equal to 14. All right, a word problem. A swimmer wins the 50-yard freestyle with a time of 24.76 seconds. Find the average speed to the nearest hundredth. So what are we saying? We're saying, okay, how far did she swim? She swam 50 yards. Now what's interesting is that should it be 50x equals 24.76, or should it be 24.76x equals 50? Let's dive into this. There is a way to figure it out when it says yards per second. So that means it's going to be distance over time is equal to x. That's what yards per second. But let's say you didn't know that. You're going to try these two. Well, I'm hoping that you see if you divide both sides here by 50, x is going to be less than 1. So you're saying that it's less than 1 mile per hour. That seems awfully slow. But if we divide over here, then x is going to actually be greater than 2. And if we get a calculator out, $50 divided by 24.76 is 22.01938. We'll stop there. But it says to the nearest hundredth. Here's our hundredth, so we do 2.02, and it's yards per second. So sometimes guessing and checking can help you. You know, what makes more sense? Being basically, this would end up probably being like 0.5 miles per hour, or being over 2. Which one would be faster? Well, this would make sense. Also, our distance over time. Our distance is 50 yards. Our time is 24.76. Temperature at 5 p.m. is 20 degrees. The temperature at 10 p.m. is -5 degrees. How much did the temperature fall? So we're saying now 20. Fall means typically subtraction. So we're saying minus x is going to equal -5. Because we need to know how much did it fall. So how much did 20 go down to get to -5? I mean, if you look at this, it should be fairly simple. You should understand that x is -25. But let's solve it. So -20. So we're going to subtract 20. I'm sorry. Positive 20. I'm sorry. It fell down 25 degrees. I'm sorry. And so we have this. This will give us -x is equal to -25. Again, we want to make this positive. So we're going to divide by -1, which would give us x is equal to 25. So we're like, well, Mr. Adams, why don't we can multiply by -1 and get the same answer? Absolutely, perfectly fine. But I'm just stating that because x is being multiplied by -1 in our term right now, we're saying we're doing the opposite, so we're going to do divide by -1. You would be correct saying that they could do both ways. Quick table. So if we have an equation of x minus 7 equals 0, what is the value of x? So if we add c to both sides, x is equal to c. If it is c times x, then we would divide both sides. And so x would equal to 1 over c. If we had cx equals c, and we divided both sides by c, x would equal 1. And if it was x divided by c equals 1, we would multiply both sides by c, and x would equal c. Okay, I have attached onto our message that there's a nice little sheet that you can work with single one-step equations. Please give that a try. It is quite a few problems, but again, they should be very quick and very short. I would highly advise you to first try to do them without a calculator if it's just single digits. If you're starting to multiply or divide by decimals, then definitely use a calculator. Thank you. See you for the next section.